We're going to attempt to do this static equilibrium problem. So we're going to call this a force 1. And we're going to call, and I'm also going to teach you an airplane problem. And we're going to call this force 2. And we're going to call this, what does that say, 1,000 pounds? Force 3. So we know that if I add up, since this object is in equilibrium, I know that force 1 plus force 2 plus force 3 has to add up to 0, right? Because those three things, because this object isn't moving. It's called this. Yeah, well, all the components, like the horizontal components have to add up to 0, and the vertical components have to add up to 0. Well, this force 1 and force 3 doesn't have a horizontal component, right? So another way to write this is that the magnitude of force 1, meaning how much, because this is just kind of a force vector, so it's got magnitude and direction, but the magnitude of that, whatever tension is on that cable, is equal to, or the magnitude of this times the cosine, I'm breaking this vector into its components, okay, times the cosine. And since it's 180, this is like 0 over here. So that angle right there would have to be what? From here to force 1. Those are called alternate interiors. Remember that in geometry? So this angle right here would also have to be 40. So you have the magnitude of force 1 times the cosine of 40 degrees in the I direction plus the sine of 40 degrees in the j direction, plus the magnitude of force 2, which is how much pressure or whatever force is on that cable, times the cosine of how many degrees? Not 25, because it's this angle from here to here. Because that makes a difference in the sign, whether it's negative or positive. So you don't call that 25, you call that, how much is that? This is 25, and that angle from there to there has to be 155, right?
150.
No.
Oh, sorry, yeah.
155, right? 180 minus 25. Cosine of 155 twice plus sine of 155j. But I'm not done yet. Sine of 155 in the j direction. Plus, what is this? How could I write this one? F3. What is it? It's just a straight down negative, because it's going down, negative 1,000 in the j direction. Right? You understand where that comes from? Because it's going down, and so it's going in the negative j direction, and it's going down with a force of 1,000 pounds. So this, what?
Is that continuing?
What do you mean continuing? Yeah, this is part of the equation I just ran out of room. Okay? So now what you do is you equate the x parts, because the thing isn't swinging back and forth, it's not being pulled over one way, it's just kind of hanging there, so it's in equilibrium. So that must mean that the magnitude of force 1 times the cosine of 40 degrees, right, plus the magnitude of force 2. I know it looks like 11, but you kind of have to indicate that it's the magnitude and not just the vector itself. The magnitude of force 2 times the cosine of 155. What do those two things in the I direction have to add up to? No. 0, because it's not moving side to side. See? And so you solve this equation for either force 1 or force 2. So you get, let's just do that. So you get that force 1. I don't like to keep writing this magnitude thing because it's a pain in the neck. Oh well, let's just do it. So force 1 times is equal to negative, what was that? Force 2. They get kind of wild next door over there, okay? Cosine 155 divided by what? Cosine of 40. Good. You see where I got that all from? Okay. So now I have an expression for force 1. And why don't we take that and plug it into our calculator? Can someone do cosine of 155 divided by cosine of 40 for me? Should get a negative number because cosine of 155 is a negative and this is a positive, right?
Negative 1.183.
Thank you. So you get that force 1, and you want to take that to pretty many decimal places, is equal to negative 1.183 times the magnitude of force 2. You follow that? See what I did? It's double or negative, so it's negative. Yep, negative. So this is negative, so it's negative, negative, which makes that positive. All right? So now we have an expression for force 1, relating force 1 and force 2. And now I have to find another expression. Well, I also know that the vertical components, when I add them together, it's not moving up and down, right? So those have to add up to 0 as well. So I'm going to go force 1 times the sine of 40 in the I direction plus, oops, I should have magnitude. Okay, plus j, sorry, sine of 40 in the j direction plus force 2 times the sine of 155, in the j direction. Has to equal up or plus, you could say plus negative 1,000 in the j direction. Has to also equate to 0, right? Because when I add those all up, they also have to add to 0. So now what I do is you could get rid of the j's, and you could just say that force 1 sine 40 plus, I'm kind of eliminating the double brackets because they're a pain in the neck, right? Sine of 155 equals 1,000. Everyone see what I did? Yeah? I've just brought this onto that side. And now I'm going to do my substitution. So I'm going to take this, okay, 1.183 force 2, and plug it in here for force 1. So now I get that 1.183 force 2 times the sine of 40, right? Plus force 2 times the sine of, did I mess something up? I don't think so. 155 equals 1,000. And then I factor out a force 2. Okay? Force 2 times 1.183 sine 40 plus sine 155 equals 1,000. Therefore, force 2 equals 1,000. Did I mess up? 1.183, right? Is equal to, force 2 is equal to 1,000 divided by 1.183 sine 40 plus sine of 155. And you put that into your calculator and you get out about 845. 845.2, and that seems to make 28, whatever, 0.3 pounds. Right? So that seems to make kind of sense, right? Because you always want to check to make sure your answers make sense. And it seems like if this is pulling straight down with 1,000 pounds, and what did we just find, force 1 or force 2? Force 2. So this one is pulling with 845 pounds of force. Now to find force 1, all I have to do is plug that back in here, right? So what's 1.183 times force 2? Times 8, what was it? 845. Times 845. What do you get there, Rach?
What? Times it by 1.
Yeah.
999.96.
999.96. That sounds like a lot, since it's all 999.96. Is that the right answer in the back of the book? We better ask Bob. Okay? You know what Bob is? Yeah, I got a book. Okay. So, let's ask Bob if we were right.